Welcome, everyone, to Noble Capital Markets Basic Industries Virtual Equity Conference, and thank you for joining us today. I am Mark Reichman, a Senior Research Analyst at Noble. It is my pleasure to introduce Mr. Carl Johnson, Chief Executive Officer, and Mr. Asher Ashari, Chief Financial Officer of Norsk Titanium, an additive manufacturing company and a global leader in metal 3D printing. With its proprietary rapid plasma deposition technology and 700 metric tons of annual print capacity, Norsk Titanium provides a cost-efficient 3D printing of metal alloys with the ability to deliver value-added parts to a very large addressable market. Norsk Titanium shares trade on the OTCQX under the symbol NORSF and on the Euronext under the ticker NTI. Welcome, Carl and Asher.
Thank you, Mark. Asher, Norsk Titanium provides forging equivalent titanium to the aerospace market and other markets. If you look at the history of forging, starting with blacksmiths, labor intensive, moving to larger forging presses, heavily capital and energy intensive, to, as you can see, our factory on the right, clean, quiet, reduced labor, capital, and energy. So highlights for us, we have developed our own rapid plasma deposition, RPD technology. We have designed the machines so that we know what the material quality will be. We're 40% cheaper. We use 75% less energy in raw materials and take about 90% less time than legacy forging processes, making us a sustainable manufacturing alternative. We are the only manufacturer in production with Boeing, Airbus, and defense OEMs. We've qualified to their specifications, and we've released our own specifications public through regulatory agencies. We have 35 RPD machines with 700 metric tons of print capacity, which can generate 300 million of annual revenues. Our process, our machines, and our software are protected by a total of 191 patents. To date, we've had more than 325 million invested in equity. 125 million of the production facility was provided by the state of New York, which we lease back. And we have strong shareholder support that have been with us throughout our journey. Next. As I mentioned, 75% less energy, 75% less raw material, and 90% less time. If you look at the picture, you can see the print head of our machine. We are a wire additive machine, differentiating from powder based. We use a plasma arc to melt the wire and then form a near net shape of the part that is to be manufactured. After we have created the near net shape, it goes back to traditional machining houses and finishing houses and is treated exactly as any other part going on the airplane or industrial application. Go ahead. So if you look at the factors driving our technology today, there is the increased labor cost, the increased commodity cost. Using less is better, and then if you look at the global scale, the titanium supply is under pressure right now due to global events. Using less of the titanium that's available helps protect the industries that are using titanium today. Next. So we have 3 state-of-the-art facilities. We are headquartered in Egeman, Norway. We have 3 machines there. We use that as the research and development center. We have 3 machines there that support development and continued process improvements. In Plattsburgh, we have our production center. There we have 22 machines capable of 440 metric tons a year. It's a large facility, as we mentioned, funded by the state of New York. And then we also have the Plattsburgh Defense and Qualification Center. That is where we do our defense work. It is isolated from other networks so that we can do defense work. Okay. So we've been on a long journey. The last 10 to 12 years were spent establishing material specifications. We've done that with the Society of Automotive Engineers. We have delivered quite a bit of material, tons of material, to customers and regulatory agencies for their evaluation. We've designed and qualified our own machines and developed the processes so that we can calibrate and maintain the quality of the material produced. And we've gotten qualified to our customers' internal specifications and put on their approved supplier list. That's where we've spent the last many years. Now we are in the process of qualifying parts and getting them onto aircraft and industrial applications. This is a bit different in that we bid on the parts. We offer significant savings and delivery time improvements. We qualify the part individually in much quicker cycle than what we've been on, and then we transition them into production. Next. If you look at the path the company chose, we did pick the most difficult challenge in producing parts for aerospace. The pedigree, the integrity of the material is the most challenging environment for metal in use. And having been able to qualify for commercial aerospace allows us to provide material for industrial applications and for engine applications and other adjacent markets. Next. As I said, we're at an inflection point for exponential growth. If you look at the commercial aerospace market, we are in production with Boeing and Airbus, and currently in production on the 2 largest titanium consuming platforms, the 787 and the A350. We are providing materials to industrial partners. Hittech takes our preforms and machines them for its customers. And in defense, in a defense market, we are in production with Northrop Grumman and General Atomics. The adjacent markets are the MRO, repair and aftermarket, and engines, as was shown on the prior chart. Next. So with Airbus, this year we signed a master supply agreement that we are on the ASL. We have qualified our material. We have qualified our machines. We have come to agreement on terms and conditions. And now the process is when they bring us more parts, they give us a contract. All of the terms are already negotiated. And on the master supply agreement, they just hang production agreements. And so we are in production on wave 1 and 2. We're expecting follow-on parts for development this year. Next. With Boeing, we have 7 parts in production. We started production in 2017. We have delivered more than 2,000 parts in support of Boeing aircraft with 100% quality and on-time deliveries. There have been a number of things that have kind of slowed down additional parts. I think those are being worked through, and we are re-engaging with Boeing's supply chain to transition additional parts this year and next. Thank you. There we go. And then DoD, we have worked with Northrop Grumman, General Atomics, the Patel organization. Northrop Grumman, we supplied material and qualified to their internal specification. With General Atomics, we are in production with them and working to our publicly released specification as well as their internal specification. We have some space applications that we're working, and we're working on a second material for the Defense Department, a nickel-based superalloy Inconel 625. We have also looked at in the defense market the offsets, reciprocal defense spending opportunities for our company. Next. In the industrial side, this is a really good example. We provide trays to Hittech for their customer ASML, who's one of the is the largest chip manufacturing company worldwide. Traditionally, the trays that Hittech manufactured were machined out of a 220 kilogram block, and the resulting part was less than 10 kilograms when it was finished. We're able to produce a 90 kilogram print that results in the same finished part, but saves significant machining time, which allowed Hittech to avoid capital investment in additional CNC machines in order to meet ASML's demand. It's been a great relationship for us, and has been, I think, very beneficial to Hittech as well.
Thank you, Carl. As Carl mentioned, we've had some major commercial wins across our markets this year. This breakthrough progress is helping us transition from a technology company into a serial production company using our additive manufacturing RPD technology to manufacture parts for OEMs. So in commercial aerospace, we signed a landmark supply agreement with Airbus and transitions parts into production for the A350. With Boeing this year, we signed a direct supplier agreement and transitioning or produce serially delivering parts now directly to Boeing for parts that are already in serial production with their tier 1 suppliers. We demonstrated our capability to produce parts that are up to 1.5 meters long using our large format machine. It's still the Gen 4 machine, but it's a larger format and larger envelope to do bigger parts. In defense, we have received our first serial production order with a prime contractor for the U.S. Department of Defense. Northrop Grumman, our material is qualified, and we are starting to look at parts that will transition into production. General Atomics has already applied our technology in critical aircraft structures for unmanned vehicles. We continue to develop our technology, and with that comes new materials. So with the U.S. Navy, we're developing Inconel 625, a nickel-based super alloy, and we're looking at how we adapt our technology to new materials and for applications in defense. Industrials is our highest volume market today. We have secured long-term agreements with Hittech for carrier trays that are installed on ASML's equipment, chip making equipment. And we have received 3 orders to date, and this represents an annual recurring revenue of approximately $2 million from this one product. In August recently, we also put on contract new parts that are now entering serial production with Hittech as well. As we transition into production, we are taking deliberate actions to increase our market penetration. To help our investors and the market understand our growth trajectory, we've developed 2 main KPIs. The first are parts in serial production. These are unique parts that are delivered to customers and installed on assemblies that are produced in series in any given month or year. Attached to these unique parts is a second indicator that we developed called annual recurring revenue for those parts in serial production. So each unique part represents a series that is delivered to them on a periodic basis, and the dollar amount represents the amount of revenue potential from each of those parts. Year end 2023, we ended with 11 unique parts in serial production that represented only $4 million in annual recurring revenue. As of the end of August, we have increased our part count to 28 parts in serial production that represents almost $11 million in annual recurring revenue. Our goal this year is to get to 60 serial production parts. And by the first half of 2025 or into 2025, those parts will represent about $50 million in recurring revenue. Our stated goal is in 2026, our long-term goal is to have over 120 parts in serial production for OEMs that generate about $160 million in revenue, in recurring revenue. So to put this in a more graphical depiction, we are reaching an inflection point in our growth trajectory. Starting year-end 2022 to about the first half of 2024, the graph on the right shows a steady growth path. However, we're projecting an exponential growth between now and 2026. So this year, our goal is to get to $10 to $12 million in revenue, and get to $50 million in recurring revenue with the parts that are transitioned into production in late 2024 and early 2025. And then grow towards 120 parts that get us to about $160 million in annual recurring revenue. So, the adoption of our RPD technology in 2024 builds the base for our 2026 targets. With the qualifications completed with Airbus, Boeing, ASML, and Hittech deliveries, that starts to create that base for 2024. As I mentioned, we expect $10 to $12 million in revenue this year, recognized revenue this year, and our target is to get to $150 million of revenue in 2026, with generating an EBITDA of approximately 30%. The little box on top of the 2026 bar chart, those are alternative business models that we are exploring and that we expect to enter into by 2026. And these are either we sell machines to adjacent markets, or we look at some IP licenses or joint ventures with customers that need higher volume and more specialized development applications. Our contribution margins from part sales today are around 30%, and they grow to about 50% as we get into 2026 with increased scale. As Carl mentioned earlier, there's over $400 million invested in this company to date to get us to material qualifications and development activities with our customers and to adopt our technology into existing platforms. So again, just closing with this slide on the financial side, the parts that are transitioned into production generate a multi-year backlog of business. And that's why the Norsk Titanium chose to go down the route of delivering parts to customers. Each part represents a reoccurring revenue and a total contract value. So the parts that we transition, the 60 parts we transition in 2024 have a contract value of approximately 2.5 times. The parts that we transition in 2026, about 120 parts, that represent 4 times that number in contract value. The chart on the right, the table on the right, shows about 20,000 commercial aerospace units produced a year, which only is about 3% of the market penetration. Industrials is about 15,000 units, about 0.5% of the market, and defense 5%. All in all, we're looking at a 3% penetration rate by 2026. That is 120 unique parts in production, with only utilizing 50% of the capacity that we have built today.
Okay, well, I'll
There
start
we
off
go.
with a few questions. First is, how is Norsk Titanium 3D printing different from other 3D printing companies?
We have differentiated ourselves first by process. Most 3D companies that you will encounter are powder based, and the business model for those businesses typically a machine sales approach. We have a direct energy deposition of wire. We produce parts. It's not our intent to sell machines initially, and we have designed our own machines and manufactured them to ensure that we can produce the material quality that our customers expect.
So could you just describe the competitive environment? I mean, how many competitors do you have in the markets you're going after?
The competitors we have, they're very limited in direct energy deposition of wire. The market for that we are addressing is structural aircraft components. Today, we are the only ones that are qualified for that application with both Airbus and Boeing and with the DoD. It has taken us between 10 and 12 years, if you will, to achieve that position, and we think we're significantly ahead of our competition in maturing the process and getting on the qualification.
Now, what is the main reason for suppliers, producers to choose 3D printing in general over traditional forging?
We offer quite a bit of flexibility in terms of shorter lead times. We can come back to a part if there's a production gap. It's simply us reloading a program. The savings that we offer, as most airframes are under constant pressure to reduce their costs to their customers, and we offer an opportunity to do that for titanium parts.
Well, I was also going to ask, I expect that if you're an approved supplier, once you're in, you're kind of in. In other words, you're able to supply a part as long as that aircraft is being made. Could you just maybe describe your operating leverage a little bit? I mean, you mentioned you're expecting to move from 10 to 12 million of revenue to 50 to 120, and your EBITDA margin in 2026 will be roughly 30%. Could you just kind of speak to kind of the contribution margin and the EBITDA margin growth over, how sensitive it is to, your production?
Yep, yep. So we expect so in terms of operating leverage, the base organization is in place today, so the operating costs are not expected to grow significantly from where we are today. As an aerospace manufacturer, you have to maintain a quality and supply chain organization that can deliver parts on time and 100% quality. So by end of 2025, we expect to break even, and by 2026, we expect that growth to rapidly increase to 30%, as contribution margins increase to 50%. So the base organization is in place today, and that operating leverage is not expected to grow as we scale, because we have the capacity available, and we have the base organization or the infrastructure of the organization available today to us.
And what percentage of your capacity would be utilized, of that 700 metric tons of capacity would be utilized by 2026?
So we expect 750% of our capacity to be used by 2026 to deliver about $150 million of revenue.
And then also was just kind of curious where you source your raw materials.
Yeah, so our titanium wire is sourced from within the United States. Plate and wire are sourced from the United States, generally from Japanese sponge and ingots that are melted here in the United States. We have a pretty solid forecast and long-term agreements that help us with the raw material side.
Well, it's a very interesting story. I was just wondering if we could maybe end on the growth drivers going forward.
Well, so a couple of them in the aerospace world. Composite airplanes, which is generally the direction the manufacturers are moving, use an increased amount of titanium to replace aluminum, because titanium does not corrode in contact with the resins in the composites. So that's helping drive growth in aerospace. Our cost position or opportunity for the aircraft manufacturers is a big driver, and our ability to be flexible as aircraft or the new designed aircraft that are coming, because we have the shorter lead time. It affords an opportunity for their designers to be able to be more creative in the time in finalizing a design, because we can respond quicker. In the industrial side, the ability to reduce machining time is really a significant opportunity as volumes increase. As we look in that market, we see a great deal of additional opportunity. And then you look at adjacent markets. You look at potentially oil and gas, the engines, the MRO. The opportunity space is huge.
Yeah, and I would also add, Carl, to on top of that, is the way our process is designed and the qualification process we've gone through. We can replace existing parts that are in production one for one, right? So as the growth in those aircrafts and those systems grow with the market, we grow with them. And in addition, we have the ability to penetrate that market further by transitioning parts that are already in production on those platforms. So the number of parts, the unique number of parts, increases as well. So there are multiple growth drivers to this company.
Well, it's a very compelling story, and thank you so much to Carl Johnson and Asher Ashari for joining us today.
Thank you.
Thank you for the opportunity.
Kevin O'Leary here, aka Mr. Wonderful. And you can meet me along with my fellow investors, Damon John and Robert Hershevik, on December 4th at Florida Atlantic University College of Business for the Noble Capital Markets 20th Emerging Growth Equity Conference, featuring 100 public companies. Who will be there? Investors ranging from self-directed to institutional, and of course the companies and their founders. I have to tell you, Robert, Damon, and I are very, very proud of the impact our venture investments have made in America's most innovative and disruptive companies. Collectively, we've invested millions in startups, and sales from those companies are in the billions. No one could have predicted a brand of socks, a cat DNA testing kit, a little sponge, and a toilet stool would be some of the top winners. That's what's so amazing about American entrepreneurship. Just one idea can change your life forever. And at NobleCon 20, the three of us will be pitched by 3 entrepreneurial ventures from Florida Atlantic community. I can't wait. I love seeing new investment opportunities. See you there.